All right, let's start. Yes, okay. So first of all, wait a minute. Six x. I can even write. Okay, hold on. Nice one. So 6x minus 3x squared dx. Okay, that's the average value. So let's calculate. The antiderivative is going to be 2x minus 3x squared minus x cubed. Okay. And then you will get 2b plus 3b squared minus b cubed divided by b. Okay. After you simplify, it's get 3b minus b squared. And this is supposed to be 3. You can solve for b. Okay. So b squared minus 3b plus 1 equals 0. And let's find out the value. Minus 4ac. Okay. So 3 plus minus square 5 divided by 2. But we cannot choose can we choose a negative sign? I think it's possible. The reason is this number, the two solutions. So b1, 3 minus square 5 over 2 is greater than 0. b2, this is also greater than 0. So there's two possible solutions for the interval. The reason is it begin with 2, right? Actually going down here. So if you go down, then somewhere here, okay, this is a, so it gives you the average value, same average value, right? All right, now we take a look at a continuous function, right? So let f of x be continuous on some interval. Okay. So it has a maximum value, it has a minimum value. Okay. This is the absolute maximum value somewhere. And this is the absolute minimum value, okay, maximum value. So the function is between these two numbers, right? Maximum. Okay, little m and capital M both are numbers. So you can integrate over the interval. Okay, what you get here is capital M times B minus A. What you get here is little m B minus A. Then you divide both sides by B minus A, you get the average value in the middle. So the average value is greater than equal to, the average value is greater than equal to the minimum value and less than equal to the maximum value. And that's reasonable because it's average value. Okay. Now, the average value, let's look at the picture here. This is the picture, okay? This is your m. This is a little m, okay, capital M. And right, the average value is somewhere here. Okay, this is the average value. Right, it's between little m and capital M. So there should be intersection point. Okay, there's the intersection point. Okay, so clearly by the intermediate value theorem, there is a number C in the interval from A to B such that so the average value is given the value of the function. I think this is the past. This is clear, right? The average value, maybe related to the average speed, right? So you get a speed function, right? It depends on time t. Sometimes draw fast, sometimes draw slow. If the average speed from one city to another city is 60 miles per hour, then somewhere, so your meter shows that your speed is 65 miles per hour. You can always below that, you can always above that, all right, somewhere. Okay, if the average value is 65 miles. Okay, so we prove that, right? This is called the what is it called? Yeah, this is called the mean value theorem, maybe. Yeah, the mean value theorem says that mean value theorem. Okay, there's a number in the interval such that the average value is going to be the value of the function. So let's look at the example to check this is true or not. Right? When you get results from somebody else, this is in mathematics, could be in biology, chemistry, right? Sometimes you suspect this is not correct. And then what do? We check that using doing by experiment, or in mathematics using example. If we find out it's wrong, you don't need to go through the whole paper to understand how do you prove it. Here's a kind of example, and the whole series is going. Okay. So here's the example. F of x equals the third root of x on the interval. This is a continuous function. Okay. I'm going to find out C in the interval from 0 to 8 such that f of c is going to be the average value of the function. If I couldn't find it, this is a continuous function, then you say the theorem, the so-called mean value theorem, proved by somebody is wrong. Okay. All right, so we get let's look at the average value. Right? First of all, you have to figure out the integral 0 to 8, the square. Yeah, evaluate this integral x to the 1/3 dx. So the antiderivative and we'll get 3/4 x to the 4/3, and all you have to do is just plot 8 for x. Now you have to simplify. 8 to the 1/3 is 2. Okay, 3/4 and 2 to the 4th power, and 2 to the 4th power, 2 squared and 4 canceled out. So the answer is 12. That's not the average value. The average value of the function is going to 12 divided by 8 and 3 divided over 2. All right. Then it's supposed to be f of c. So what is f of c? That's going to be c to the 1/3 equals 3/2. So what is c? C equals 3 over 2q. 27 over 8. Is this number smaller than 8? Is it in the interval from 0 to 8? It is, because this is smaller than 8. Why? It's obviously smaller than 8. Because 27 is less than 64. So this indeed is a number. Okay? So everything's fine. Then we just trust it. Okay, because we randomly pick up an example to check the theorem, and then we find it's correct. And the chance that theorem, without even proving is true, is very high. Okay. There are some published results in biology, in medical science, because of researchers that modify the data, and so it's possible it's wrong. Okay, but you cannot tell until some research team decided to do the repeated experiment and cannot get the same result. That was a famous story by a professor in Harvard University. Yeah, you can find on the internet. I think it's kind of similar like reproducing the cells after you do something like okay, and actually nobody can do it. The difference between mathematics and biology is after you do similar experiment, then you can jump to the conclusion this is true in general. But later on, maybe will be modified. So that's why you have to always revise the textbook every 10 years. And because you conclude too much. Mathematics, as long as the proof is correct, this will be true forever. Okay, it's not, don't need to revise it. Okay. So for textbook in calculus, we keep getting new versions, new ideas. Actually, the material itself, it's already pretty standard material. You don't need to revise it. Okay, you can use a textbook forever. Almost just like a first grade textbook, right? First grade textbook, math book. Do you need a new version always? Probably not. The book maybe in 1965 is the best book forever, because first grade students just learn how to do addition, right? Addition, let's use that. Nothing new there, right? But calculus is also pretty mature right now. Right. So we look at the example. We verify this is mean variance theorem. Even you without understanding how they prove it, right? You should accept it, because the random replicative example, we find out it is true. The average value is going to be the value of the function at some point in the interval. We find out the number C. We find out is 27 over 8, which is indeed between 0 and 8. Okay, so that's okay now. So we just accept the mean variance theorem, and the statement is easy to understand. The average value should be the value of function at some particular number, right? And if you still don't understand that part, then you should imagine the average speed is 65 when you drive over the whole trip, right? And then somewhere your speed is equal to 65 per miles, 65 miles per hour. Okay. So we have 3 problems to do on the quiz. So I'm trying to give you more time to finish. So let me stop here.